But let's discuss about functional notation. We know the equation of a function is written in the form y is equal to, let's say, y is equal to 2x plus 2, right? But when using functional notation, the above equation can be written as f of x is equal to 2x plus 2. This is read as what? As f of x is equal to 2x plus 2. I'm just giving this as an example. This is how we write an equation using functional notation, right? So it means f of x is equal to y, or y is equal to f of x. Okay, right. So the y values correspond to the x value given by f of x. Let's say, for example, when you're given that f of x is equal to 2x plus 2, and then we say if x is equal to 3, then f of 3 is equal to 2 times 3 plus 2, and f of 3 is equal to 8. So it means that if x is equal to 3, y is equal to 8. Also remember that we can use different notations for the y values. Okay, we can use h of x, we can use m of x, t of x, etc. Okay, it's not just f of x only. So for different functions, we may use different what notations, but all these mean what? Mean y. And then how do we represent the inverse function? The inverse function of f of x is written in the form f to the power negative 1 x, like that. Okay, this means the inverse of f of x. The inverse for g of x, we can write it like this, or even sometimes you can write it like what? Just this is fine. Even this is just fine for the inverse. So this is the functional notation that we're going to be using as we deal with functions.